Hello everyone, welcome back to another video. So today we will discuss solutions for weekly contest 387, and I was able to solve all four problems pretty quickly. So I'm recording so early. So let's start with first question. So in first question we just need to simulate all this. So we are given an array of length n, and we have to uh, create two new arrays based on first array in some operation. So you append nums of 1 into first array, nums of 2 into second array, and then for afterwards operation you follow this. So if the last element of first array is greater than last element of second array, you append current element into first array, otherwise you append the element in second array. For example, here 213, I will, after first two operations, in first array there will be 2, in second array there will be 1, and now in third operation the last we have to check last element of both the array. So last element of first array is 2, last element of second array is 1. As 2 is greater than 1, we have to append current element to array 1. Similarly, you can simulate for this. First, after two operation, array 1 is 5, array 2 is 4. For third operation, we take last element of both the arrays. 5 is greater than 4, so append nums current element to array 1. So array 1 becomes 5 3, array 2 remains 4. Again, we will check the last element for last operation, and array becomes 5 3 and 4 8. And we have to return concatenation of both the arrays. So 5 3 and 4 8 are array 1, array 2. So result must be 5 3 4 8. So basically concatenation of both the arrays. So just pretty simple brute force, or pretty simple brute force. So basically implementation problem. So what I did was to declare two vectors b and c, perform to first operation. So a of 0 in first array, a of 1 in second array. Now I'm iterating from 2 to n, and if b dot back is greater than c dot back, so dot back basically returns last element. If uh, if the array size is positive, if it is 0, this will give you runtime error. So if b dot back greater than c dot back, I will push a of I into b, else I will push it into c. And I'm just adding every element from vector c to b and just returning b at the end. So this was first question, pretty simple. Now we move to second question. Now in second question we are given an matrix and an integer k. So we have to return number of submatrices that contain top left element of the grid, and sum is less than equal to k. So let's take this example itself. So first let's try to understand what do you mean by keeping the top left element in submatrix. So we have to keep this element always in submatrices as per the given condition. So what are possible submatrices? First is that cell itself. Second is this cell, this two cells. Third is this three cells. Then again fourth option is these two cells. Then this, and then this. So for each of these submatrices, we have to check if the sum is less than equal to k, and if it is less than equal to k, we just increment our counter and find answer. So let me just explain first is this. So 763 and 661. So in this case, k here is 18. So what are the possible options we have? So first is this 7 itself. So this 7. Second option is 7 comma 6. 7 plus 6 is 13, still less than 18. So this 7 comma 6 in topmost row. And third option is 7, 6 and 3, because 7 plus 6 is 13, 13 plus 3 16, less than equal to 18. And now in the topmost row we got 3 submatrices, and in first another option is this vertical submatrices with this 7 and 6. So this adds one more, and there are no other possible options, because if we take this submatrix 7 plus 6 13, 13 plus 12 25, which is greater than 18, and if we move again right side, the sum will keep on going, keep increasing. So what we have to do, we basically want, so let me just draw a matrix for example. So this is always included whenever for a cell, let's say this J, I have to find sum of this submatrix. Similarly, if I am at a point K, or let's say K1, I have to find this sum of this submatrices. And if I am at last position, I have to find this. So this is some kind of prefix sum type of concept, where if I am at this position, I have to find elements which are present in this submatrices. And if you try to find indices, you will find a relation where if this has, let's say, x1 comma y1 indices, so all the elements in this submatrix will have index, let's call it I should be less than equal to x1, and uh, j should also less than equal to y1. So this kind of submatrix. Now how can you calculate this prefix sum matrix? So it's similar to a tabular DP, when you try to fill all the elements in that. So first observation is, for first row and first column, sum will always be let's say here is 7. So first is always the number itself. Now for 6, if in original matrix there was 6 in this set, so sum of this submatrix will become 13, and for this submatrix sum will be the element before the uh, sum at indices before this plus current element. So 13, if there was 5, so 13 plus 5 18. Again, if there was 4, so 18 plus 4 22. So we can calculate this first row. Using the same idea, we can calculate this first column. Now for all the elements other than this. So now I know this, I know this. Now I have to calculate this. So what I can do is, I want to calculate this. So I can use this sum, and I can use this sum. So this type of I have to calculate this block. So what I can do, take this sum first. So row wise sum of its leftmost index, its left index prefix sum. So this will represent this this portion plus this portion. Now what, this portion got added twice, so only this cell. So I have to subtract it once again. So subtracting it once and adding this j separately. So a of whatever element was there present here. So basically what I'm doing is, for calculating at this position, I'm adding the submatrix before it, adding the submatrix above it. Now there will be a some submatrix which is repeating twice, so I'm subtracting that and adding current element. So if you, let's try to see it by code, it will help more helpful. So I have declared a dp vector and I have uh, calculated r and c. R is rows, c is columns. Now I will fill the first cell of dp with first element, then I will fill whole column first, then again fill whole row. And for all other cells, what I'm doing is I'm storing, first I'm calculating the submatrix on the left of current element plus the sum of submatrix above that element, and then there will be a repetition of common matrix between these two matrices, and I will add current element to it. So I got the prefix sum at position I and j. Now I will just check all the positions, and the prefix sum is, if it is less than equal to k, I will just increment counter and return empty. So this is some type of concept which will not come directly to your mind. You have to just remember or learn this type of concept. So you will find a article for this type of concept on Geeks for Geeks. If you still don't understand it, you can read it. So you need to understand the visualization of that uh, matrix, how I calculated the prefix sum of such for a matrix based on two matrices which I calculated before. So yeah, that's it. This was second question. This was also pretty easy. If you know the concept, it is very simple. Now third question, I think, yeah. So in third question we are again given a grid of n cross n, and we say y, letter y belongs to the grid if diagonal from top left and starting from top left and ending at center grid, and the diagonal, so basically y n here is always odd. So if we just create a matrix of size, let's say 5 comma 5 into 5. So letter y means all the cells present in this y shaped character. So this cell, this center cell, this cell, and this cell. So diagonal starting from top left to ending at center cell. So this first slanted line. Then diagonal starting from top right cell and ending at center grid. So this second slanted line, and the vertical line starting from center side and ending at bottom border. So this is letter y, and all the cells except letter y are second type of cell, and we have to check that all the values belonging to y are equal. So these all the cells should have equal value, and all the cells which do not belong to value should also have equal value, but the values between in the y cell and not belonging to y cell should be different. And in one operation we can change any uh, value at cell from any value to 0 or 1 or 2, and also we are given condition that the cell only contains value 0, 1 or 2. So let's take the first example. One, so and this is first y, and if you try to put all the elements equal to 1 in the y cell, I just need to change this to 1. So number of operations here for just making all the cells in y shape equal is 1, plus now I have to make all the elements which do not belong to y equal to equal, make them equal to. So I can make all other 5 elements equal to 0, so I have to change this 2 to 0 and change this 1 to 0 again. So here I require 2 operations, so total number of operations required here is 3. So answer here is 3, and if you try to calculate any other answer, it will always be greater than equal to 3. So this is also pretty simple to understand what to do in this question. So for making all the elements equal to y, let's say, also so for making all the elements from in the cell y equal to, let's 0, I need total number of operations. So total number of cells, total y cells minus frequency of 0 in this y shaped cells. So if there were 6 zeros, for example here, and total number of y cells in this 5 into 5 matrix are 3 plus 3 5 and 5 plus 2 7. So I just need to change one cell here, which was either 1 or 2 to 0, such that all the elements become equal to 0. So similarly I can use this formula for if I have to make all the cells from uh, all the cells in the shape equal to 1. So what I can do is I can just calculate total y. I have calculated total number of cells in y minus frequency of 1. So frequency of I have to make all the elements except 1 equal to 1. So this is the formula for 1. Similarly I can use this for total number of y minus frequency of 2. This was about all the cells present in y-shaped cell. Now second option, for second type of operation, now we have to make all the, let's say we have to make all the elements from non-y cells. So it will be equal to again total number of non-y cells minus frequency of 0 in only non-y cells. So this frequency is only in y cells. Similarly for 1, total number of not y cells minus frequency of ny of 1. I can same calculate for 2. And now what I have to do, I have to check all the combinations of unequal cells. For so if I say I have to make all elements of y equal to 0. What are my options? Make either non-y cells equal to 1 or equal to 2. Similarly, if I choose this one, I can make either them other cells 0 or 2. Similarly, 2 to 1 and 2 to 0. So I have to check all the combinations and try to find minimum answer for this type of uh, combination. So first of all, I created two maps, two basically vectors of size 3 to store the frequency of 0, 1, 2. So y for storing cells in present in that y shape, y2 for not present in that shape. And I have declared a widgeted 2D vector. So to find the non-white type of cells. So first I am iterating from top left to center right. Then I am iterating from center top left to center, then center to bottom of the grid, and then from center to top right again. And I'm incrementing this frequency map, and I'm also making the cell as visited, and all the non-visited cell becomes non-y cell. So for that I am incrementing y2 of a of I and j. So I am mapping them into second map, which is y2. Now I also calculate total number of cells by just incrementing integer, and so total number of y2 cells will be equal to n into n minus total number of y cells, and I have declared an answer as int max. So I'm just checking all the combinations where if I not equal to j, because both of them cannot be equal. I'm calculating first uh, number of operations for making all the y cells equal to I, that will be equal to total minus y of I, and total number of operations to make all the elements of non-y cells equal to j, that will be equal to total 2 minus y2 of j, and just taking the minimum of both of them. Pretty simple to understand this question, just kind of implementation heavy question, because this iteration is takes time to understand, and there might be some runtime error issues if you don't write proper conditions. So this was third question. Now we will move to fourth question. Now this fourth question, I think I solved it I solved it with using policy based ordered set, policy based data structure. So if you don't know this, I will say uh, you you can try to understand it from, I guess there is. So what ordered set is and what policy based data structure is. So uh, let's try to understand what is a difference between normal set and policy based. So in set, let's say I added elements 1 2 3. Now in set I cannot get the position of this 2 in the whole set because it is unordered. So I cannot do anything about the number of elements less than 2 or greater than 2. So I don't have any information about the elements greater than any element or any less than that element. But in ordered set, I have the information of elements which are less than 2. So this is basically the difference. And if if you say I can use just vector, but in vector insertion I cannot use a sorted. I need to sort vector every time, because to use concept like lower bound or basically binary search, I need vector to be sorted, and sorting it in every iteration makes the complexity n square. But in ordered set I don't need to sort it, it will just sort it in log n. So while inserting a new element, plus I get the idea about basically index of current position. So I just moved on to ordered set. Let me just explain the question first. So we are given a nums of length n, and we again need to simulate this solution same as first question, but here conditions are more uh, complex. So in first operation is to append first element to array 1, second operation is to append second element to second array, and for afterwards operations, greater count, we have to find this function. So greater count array comma val returns number of elements in array that are strictly greater than value. So if greater count of array 1 comma nums 1 is greater count of array 2 comma nums 2, we append current element to array 1. Similarly, if it is vice versa, we are append current element to second array, and both of them, if both of them are equal, I will append current element to the array which has less size, and if there is still tie, I will just append it to first array. So there are multiple cases. Now there is also a modification from ordered set. In ordered set I cannot differentiate between two equal elements, as the basic rule of set is unique elements. So I cannot identify this two twice, and I don't think there is a multiset in ordered set. So what I can do is I can add 2 comma index of that element. So if I make a pair and insert 2 comma 0, and here insert 2 comma 1, so I can uniquely identify both the elements differently, and set will also make the consider them different because this pair is different. So this is slighter modification, and this is very simple question of ordered set. Let me just show you the code. So this is first, you have to use this template. I use this ordered set, and same I declared two vectors, two ordered sets. I added the first element to first array, second element to second array, then inserted both the elements in st2, and I inserted pair, so a of 0 comma 0, a of 1 comma 1. Now there is function known as order of key. So order of key basically returns number of elements strictly lesser than the key. So I am here passing a of I plus 1, so it will return all number of elements which are less than a of I plus 1. So basically number of elements which are less than equal to a of I. Now for finding all the elements strictly greater than a of I, we just need to subtract this value from original array size or current array size. So b dot size minus st dot order of key of a of I plus 1, and this will return count of number of elements strictly greater than the current element in array 1. Similarly, c2 will return find is the number of elements strictly greater than current element in array 2. Now if cnt greater than cat2, I will just push it in first array. Else if counter 2 is greater than counter 1, I will push it in second array. If b dot size is, and if both of the counters are equal, and if b dot size is less than equal to c dot size, I will push it in b, else I will push it in c. And I am just concatenating both the arrays and returning b. So this is a very simple question as for fourth of Leetcode, because this is very standard question of ordered set. If you know ordered set, you will easily solve this question. There is no hard implementation also here. You just need this template. And yeah, that's it from my side, and thank you for watching.